Hello, thank you for joining me for another episode of the Leukopak Lady. I'm continuing from the last episode talking about approaches teams use to manage variability in starting material as programs scale. Once variability becomes visible at scale, teams look for ways to manage it. One increasingly discussed approach is pooling or batching donor material. This is an intriguing approach, but it is not the best solution for every program. First, let's talk about why this approach is attractive. It averages out donor variability, it reduces batch-to-batch swings, and it improves consistency in input metrics. At its core, pooling is a statistical solution to a biological problem. And it's a very common approach across many manufacturing systems, including biologics, plasma-derived products, and vaccines. Pooling starting material for cell and gene therapy works best when donors are already biologically similar, variability is relatively small, and the process tolerates mixed inputs. In these cases, pooling improves consistency without masking biology. However, pooling doesn't eliminate variability, it redistributes it and can introduce new risks. It can mask high and low performing donors, it can dilute strong biological performers, it can introduce incompatibility between donor cells, like HLA type, and it can complicate traceability. Therefore, a good donor and CSM strategy is still needed even when pooling is used. Pooling smooths variability on paper, but biology doesn't always average cleanly. Pooling may reduce peak performance, increase process complexity, and introduce new regulatory considerations. So let's talk about these regulatory considerations. The FDA is not anti-pooling. They don't prohibit pooling of donor material, but they do care about product consistency, safety with respect to infectious disease risk, traceability, and manufacturing control. The same regulatory strategies used for pooling in other industries can be difficult to apply to cell therapy. Donor-to-product traceability is expected, and donors must be independently eligible. There are regulatory precedents for pooling blood products, such as cryoprecipitate, where manufactured units from individually qualified donors are combined into controlled pools for patient treatment. However, applying these models directly to cell therapy is more complex due to living cell behavior and functional variability. Mixed donor cells with different HLA types represents the most significant risk of pooling both before and after manufacturing because of the danger of alloreactivity. This is where regulatory scrutiny would be the highest. Groups are working on this, so expect some regulatory precedent in the future. The best approach when a program wants to use pooling of donors or donor-derived manufactured batches is going to be making it part of the process design from the very beginning, maintaining strong characterization and control over the final product, demonstrating consistency between pooled batches, and employing it only when the mechanism of action is not donor-specific. Regulators will want to know that pooling is being used to control variability, not hide it. So then if pooling doesn't solve variability, the next instinct is optimization. Can we just find the perfect donor? Join me on the next episode for that discussion.